Okay, so this is a simulation that looks at reaction rates as well as collision theory. So the idea that molecules have to collide and the bonds break for a reaction to occur. So let's look at our reaction. This is the model reaction. So molecule A, which is this ball, is going to collide with molecule B, which is this ball bonded to this gray ball. And if we look at the other side, right, A and B are going to switch, right? So A is going to form a bond with B, and then C is going to be left by itself. This type of reaction, what we call that is we call that a single replacement reaction. It makes sense, right? We're just swapping positions. So here's our energy, right? So the other piece is the energy. There needs to be enough energy for the reaction to occur. And so what happens is we hit this peak, right? And the reaction can occur. These two arrows mean that this reaction is in equilibrium, which means it can go in either direction. So just as easily as we can swap A and B, right, they can swap back. So they can go from what they are now. So let's just pull the plunger, get the things going, right? Boom. So you can see the collisions happening, right? They're swapping positions and then they're swapping back. And we can see how the energy is moving, right? So now they have to hit each other just right to break the bond. Okay, so before they hit each other just right. So now let's throw the reaction rate. So temperature can affect the rate of the reaction. And so if we include temperature into this, start to raise it, so you can see little fires, things are starting to speed up. So what do you think is going to happen? They move faster because of the temperature, and as they move faster, the rate of reactions increasing, we also have more collisions, right? So at some point, these guys are going to collide, and they're going to do that replacement reaction. It's getting kind of hard to see, right? But you can see how they swap positions. So I can slow this down. So like I said, if you can install this, you can kind of play around with it on your own. And we'll look at some specific examples. So this is just demonstrating how energy falls into it, the reaction rate. The energy is the amount of energy that we have to overcome. We have a certain amount of energy we need to reach, right? So if this axis is time and this is energy, we need this much energy for those bonds to break. So if I reset this, right, you can see how this is the reaction in equilibrium, right? They're just switching positions. Real simple. Right. And you can see how the energy moves when they collide correct in the way with enough energy so that the reaction actually happens. Right now, there isn't enough energy. I can raise it. Make things go faster. So reaction rate, think of temperature. And there are other things that we can do to affect the reaction rate, which we'll talk about as well. You could watch this forever. It's pretty cool.